Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. CPU and RAM failures are among the most disruptive hardware issues a system can encounter, often resulting in crashes, freezing, power loss, or failure to boot. These types of failures may be intermittent or immediate, and they frequently present symptoms that overlap with other hardware problems, making proper diagnosis essential. Root causes can include improper configuration, physical component failure, or environmental factors such as heat or dust. Understanding how to detect, isolate, and resolve CPU and RAM issues is a core competency tested on the A+ exam and required for effective field diagnostics. Overheating is one of the most common CPU-related problems and presents in several recognizable ways. A system that suddenly reboots, powers off during operation, or refuses to complete post may be shutting down to protect the processor from thermal damage. Other signs include excessive fan noise as the system tries to compensate for high temperatures or visible slowdowns caused by thermal throttling. Monitoring tools and BIOS settings often report these high temperatures, giving technicians a clear starting point for investigation. The causes of CPU overheating generally fall into three main categories: failed cooling components, poor thermal interface, or environmental obstructions. A CPU fan that has failed, disconnected, or become jammed can no longer move air across the heatsink, quickly leading to overheating. If thermal paste has been improperly applied, dried out, or is missing, heat cannot transfer efficiently from the CPU to the cooler. Additionally, a buildup of dust on the heatsink or inside the case can restrict airflow, trapping heat and pushing temperatures beyond safe limits. Overclocking without sufficient cooling capacity can also cause instability and thermal shutdown. Resolving overheating issues begins with addressing the most immediate physical factors. Technicians should remove dust from fans, heatsinks, and air filters using compressed air. If thermal paste has degraded, it should be thoroughly cleaned and reapplied according to the manufacturer's recommendations. Case airflow should be reviewed, ensuring that intake and exhaust fans are positioned to provide proper circulation. In systems that continue to overheat under normal load, upgrading the CPU cooler or case ventilation may be required to maintain thermal stability. Thermal management tools and BIOS settings are essential for monitoring and controlling CPU temperature. Most BIOS interfaces include real-time temperature readings at startup, which can give an immediate clue to overheating. BIOS also allows adjustment of fan curves, which control how quickly fans spin as temperatures rise. For more advanced tuning, third-party software can provide continuous temperature monitoring, historical graphs, and even CPU utilization trends. These tools allow technicians to track how the system responds under load and whether cooling measures are effective. Freezes and crashes caused by the CPU often occur under high load or during specific tasks such as gaming, video rendering, or running virtual machines. These symptoms may appear as sudden lockups, unexpected application closures, or even full system crashes that result in a blue screen. In many cases, system logs will point to processor-related events such as timing errors or hardware exceptions. Because the CPU handles nearly every system instruction, even a minor defect can cause major instability across the entire operating system. Testing CPU health involves both software and observation. Stress testing utilities can simulate heavy workloads and help determine whether the system remains stable under pressure. Built-in diagnostics offered by some motherboard manufacturers can also help identify failing CPUs. During these tests, technicians monitor both temperature and performance for signs of error. If failures occur repeatedly despite proper cooling and BIOS settings, the CPU may need to be replaced. Replacement is only recommended once all other potential issues, such as power supply or motherboard faults, have been ruled out. RAM-related instability shares many of the same symptoms but typically includes additional signs that point directly to memory. These include random reboots, frequent application errors, or inconsistent system behavior. When RAM is at fault, the system may produce post-beep codes or LED indicators that reference memory problems. In more severe cases, the system may fail to load the operating system entirely, or the screen may remain blank after powering on. These issues can be frustrating because they often appear sporadically. To diagnose RAM problems, technicians use memory testing tools that examine how the modules perform under read and write operations. Windows includes a built-in memory diagnostic tool that runs during boot, while MemTest 86 provides a more thorough testing environment from a bootable drive. Testing one module at a time allows for isolation of the faulty stick. It's important to log test results and repeat the test if errors are detected, especially when working with large amounts of memory or unfamiliar hardware configurations. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. When a memory module is suspected of causing system instability, reseating or replacing the RAM is often the next step. Begin by fully powering off the system and grounding yourself to prevent electrostatic discharge. Carefully release the retention clips and remove the memory sticks one at a time. When reinstalling, ensure the module is aligned correctly with the notch matching the slot, and press down evenly until both clips snap into place. If multiple sticks are installed, boot the system with one stick at a time to identify if a specific module is faulty. Testing each stick individually helps isolate problems and confirms whether replacement is necessary. BIOS settings can also impact memory behavior and stability. Many modern systems include features like XMP profiles that automatically overclock RAM to run at speeds higher than the standard JEDEC specification. While this can improve performance, it may also introduce instability if the modules or motherboard cannot handle the higher settings. Misconfigured voltage or frequency settings can result in boot loops or blue screens. Resetting the BIOS to default settings is often the best way to rule out configuration errors during troubleshooting. Compatibility issues are another potential cause of RAM failures or system instability. Mixing memory modules of different speeds, capacities, or voltages can lead to unpredictable results. Some systems may boot with mismatched RAM but only function in single-channel mode, which limits performance. Others may not boot at all. Always check the motherboard's qualified vendor list to verify that the RAM being used is officially supported. Even when modules are physically identical, electrical tolerances or firmware differences can prevent them from working reliably together. Dirty or oxidized memory slots can also cause boot failures or intermittent issues. Over time, dust, moisture, or corrosion can interfere with the connection between the RAM module and the motherboard. If a stick of RAM repeatedly fails to be recognized, inspect the slot for signs of damage. Use compressed air to clean out debris and examine the contacts for wear or discoloration. Avoid touching the gold contacts on RAM sticks directly, as oils from your skin can degrade signal integrity over time. If multiple modules fail in the same slot, the motherboard itself may be the problem. When memory is faulty, it can produce a wide range of system errors. These include blue screens referencing memory management or system service exceptions, application crashes, or failures to install software. In some cases, corrupt memory can cause file corruption or prevent the operating system from loading properly. Technicians should be alert to these symptoms and consider RAM as a possible root cause, especially when errors are inconsistent or affect unrelated applications. There are situations where CPU socket or motherboard faults may mimic memory problems. If good RAM fails across multiple slots, the issue may reside in the memory controller, which is integrated into the CPU on most modern systems. Bent pins in the CPU socket or motherboard trace damage can disrupt memory access and cause errors that appear to be RAM-related. Technicians should inspect the socket carefully during CPU replacement or reseating, especially if memory tests fail without any one module consistently causing the error. Replacing a CPU or RAM module involves matching the hardware to the existing system configuration. For CPUs, this means ensuring the socket type and chipset are compatible with the motherboard. RAM must be compatible in terms of generation: DDR3, DDR4, DDR5, speed, and voltage. When reseating a CPU, apply a fresh layer of thermal paste, mount the cooler securely, and reconnect the fan header. After replacement, boot the system and verify that POEST completes successfully and that all installed memory is recognized by the BIOS or operating system. Post-replacement testing ensures that the new component has resolved the issue. After replacing RAM or a CPU, the system should boot cleanly and load into the operating system without errors. Run stress tests and monitoring tools to evaluate stability under normal and high-load conditions. Check system logs for any residual errors and verify with the user that normal functionality has been restored. Only after confirming that the system is stable should the ticket be closed or the repair logged as complete. A common real-world example of RAM troubleshooting might look like this. A user reports that their system crashes every time they use Microsoft Excel. The technician runs a memory diagnostic and discovers that one of the installed modules fails during testing. After removing the faulty stick and retesting, the system remains stable and Excel runs without issue. The technician replaces the bad module, verifies full functionality, and documents the resolution in the support system. This kind of problem illustrates how subtle hardware faults can manifest as application-level failures. In summary, CPU and RAM failures can lead to some of the most frustrating and persistent system problems. Technicians must carefully analyze symptoms, use the correct tools, and approach each step methodically. Overheating, misconfiguration, and physical damage are common issues that can be addressed through proper cleaning, reseating, testing, and replacement. Compatibility must always be checked and BIOS settings reviewed. These hardware diagnostic skills are essential not only for passing the A+ exam, but also for ensuring stability and performance in real-world computing environments. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.